Since astronomers began finding exoplanets in the 1990s, they've uncovered a lot of hot Jupiters, and now NASA's most venerable telescope is playing meteorologist. These colossal worlds are gas giants like our own Jupiter, but orbit much closer to their parent stars, close enough that their surfaces might boil at stomach-churning temperatures above 3,000 degrees Fahrenheit, 1,600 degrees Celsius. Now, the Hubble Space Telescope has pierced the veils of two different hot Jupiters, finding some rather bizarre weather, at least by the mundane standards of our solar system. These worlds are more than curiosities, they're evidence of how a star can influence an orbiting planet's atmosphere. We still don't have a good understanding of weather in different planetary environments, David Singh, co-author on papers describing the two planets, and an astrophysicist at the Johns Hopkins University in Maryland, said in a statement published by the Space Telescope Science Institute, which operates Hubble. "When you look at Earth, all our weather predictions are still finely tuned to what we can measure," Singh said. Not so at an exoplanet, he noted. Even though you know the basic chemistry and physics, you don't know how it's going to manifest in complex ways. One of Hubble's targets was KELT 20b, a hot Jupiter located about 400 light-years away from Earth that is described in a paper published in Astrophysical Journal Letters in January. Here, Hubble found evidence that the intense ultraviolet radiation from an overbearing sun slams into the planet's upper atmosphere, where metals absorb it. The result is a superheated layer high in KELT 20b's atmosphere, like Earth's ozone-rich sun-blocking stratosphere, only many times hotter. Until now, we never knew how the host star affected a planet's atmosphere directly. There have been lots of theories, but now we have the first observational data. Guang Weifu, an astronomy graduate student at the University of Maryland and one of that paper's authors, said in the statement. "This is compelling evidence that planets don't live in isolation, but are affected by their host star. But KELT 20b is positively benign compared to what Hubble found on WASP 178b, located 1,300 light-years away and described in a paper published, opens a new tab, Wednesday, April 6, in Nature. On this planet, it rains rocks. The strange precipitation occurs because one side of the planet always faces its sun, which vaporizes rock and produces gaseous silicon monoxide. That silicon monoxide flows around to the planet's nightside, at speeds faster than 2,000 miles per hour or 3,200 kilometers per hour, no less, where temperatures might be cool enough to solidify the material back into rocks that fall back to the surface. For astronomers, these strange worlds are more than just curiosities. The observations are evidence that modern equipment can give scientists glimpses into the climates of other worlds, something that might help them find less hellish, more Earth-like worlds. If we can't figure out what's happening on super-hot Jupiters, where we have reliable solid observational data, we're not going to have a chance to figure out what's happening in weaker spectra from observing terrestrial exoplanets, Joshua Lothringer, an astronomer at Utah Valley University, and one of the authors of the second paper, said in the same statement. Image credit, NASA, ESA, Leah Hustak, STScI.